Welcome back to another episode of Fun Mineral Facts with Flick. I'm Flick, an internationally certified gemologist, and today we're going to be talking about the Mohs Hardness Scale. And I know a lot of you are probably like, I'm very aware of the Mohs Hardness Scale, Flick. Why are we talking about this? Everybody knows what it is. But truth be told, I see a lot of people misunderstanding and misusing the scale. The Mohs Hardness Scale was developed in the 19th century by German mineralogist Friedrich Mohs, and it was developed as a way to determine the relative hardness of minerals. Take note there, the hardness of minerals. Now, I see a lot of people misusing the Mohs Hardness Scale in the sense that they use it to determine the strength of a mineral and the tenacity of a mineral, where that has nothing to do with it whatsoever. The Mohs Hardness Scale purely indicates a mineral's ability to resist scratch. I'm going to give you an example of how the Mohs Hardness Scale has nothing to do with the tenacity or the strength of a mineral by talking about two different crystals. So let's take gypsum, for example, satin spar, which is a 2 on the Mohs Hardness Scale, and diamond, which is a 10 on the Mohs Hardness Scale, as high as it could possibly go. Now, if I was to take a rod of selenite or a rod of satin spar and whack it with a hammer, yeah, a little bit might break off, but it would be relatively fine. But if I was to do that same thing to a diamond, it would just completely shatter. The Mohs Hardness Scale goes from 1 to 10, with talc being the softest and the easiest to scratch, and diamond being the hardest and the most resistant to scratch. Minerals like gypsum, fuchsite, and muscovite all fit on a 2, and that is around about the same hardness as your fingernail. Minerals that fit under a 5 on the Mohs Hardness Scales would include hemimorphite, apatite, and turquoise, and they have the same relative hardness to glass. Most spinels and beryls will fit on an 8, ruby and sapphires come under a 9, and then we top out the table with diamonds at a 10. Putting different minerals together of different hardnesses will cause them to scratch each other and essentially grind them all down over time, which is why I've never been a fan of the whole crystal confetti trend. Have you ever received a bag of crystal confetti and noticed at the bottom of it, it's full of like fine dust or fragments from your crystals? If you're pro crystal confetti and you want to keep making it, absolutely by all means, but my recommendation is to use the Mohs Hardness Scale and keep the groups of minerals that you put together within 1 point of each other to reduce that likelihood of scratching and grinding. Having a good understanding of the Mohs Hardness Scale and using it appropriately can go a long way in your mineralogy journey.